Each and every student, join the class on time. Watch the complete lecture. Kindly do not skip any classes. There will be a discontinuity in the way that you learn the concepts which will disturb your preparation. Join the class on time. Watch the entire lecture. Watch the complete lecture. For example, today, that is Saturday, if I am taking LCM and HCF session number 1, most likely by Monday night, you should revise the lecture that you have attended. Within 48 hours, you should revise the entire lecture and clarify all your doubts in our Telegram link. Attend all the classes. LCM session number 1, the concepts which I am discussing in session number 1, I will carry forward the concepts in session number 2. I will carry forward the concepts in session number 3 and session number 4. So the structure of today's class is, the first we will discuss entire LCM. As you know, I use a thematic based learning. What is thematic based learning? We will start from basics. We will start from the definition. Then we will discuss basic foundation level problems, then intermediate level problems, then advanced level problems, then previous year exam model questions. Each and every subtopic, whichever I am going to discuss in any domain of aptitude, the structure will be like this. Right from basics, any student who is coming from a non-mathematical background, any student who want to revise the fundamentals, I will discuss starting from the basic definition of the topic which we are going to discuss, and we are going to end the topic with the exam model question solved. You are not expected to go through any book for reference, everything comprehensively in detail with maximum number of problems in the class. I am going to discuss it. Maybe as a practice you can refer a book and learn the concepts from me and practice it from any other material that you wish. We'll get into the class. These are the 5 concepts which we are going to discuss in session number 1. In session number 1, we are going to discuss LCM. LCM. What are the concepts that we are going to discuss in LCM? What are the various models to find the LCM? What are the various models to find the LCM? How to eliminate incorrect answer options? How to eliminate incorrect answer options using the definition of LCM. Then we will discuss what if it is, how to find out the LCM of the given numbers. These what everybody knows it. What if LCM is given? What if LCM is given? One of the numbers we have to find. One of the numbers we have to find. LCM of A comma 20 equivalent to 60. LCM of A comma B equivalent to 72. Any Tom, Dick and Harry can find the LCM of the given numbers. LCM I will give. We have to find out one of the numbers. We have to find out one of the numbers. Or we have to find out all the numbers if the LCM is given. For example, LCM of ABC equivalent to 361 square. What textbook will teach you? This problem, generally it is an advanced level problem. It will take 5 to 7 minutes to solve the class. At the end of the class, you will be able to solve the question in less than 10 seconds. One of the number we have to find out. All the numbers we have to find out. What if the positive reminders are same? What if the positive reminders are same? What if the negative reminders are same? What if the negative reminders are same? Where all, why am I going through LCM? What is the application of LCM? Where all LCM can be used? Where all LCM can be used? How to find out the LCM of fractions? How to find out the LCM of fractions? What in some steps? What in some steps negative reminder will be same? What in some steps negative reminders are same? What if the positive and the negative reminders are not same even in some steps? What if the positive and negative reminders are not same in some steps? This is what we are going to discuss in the session number 1. Again, I am repeating, in session number 1, most likely we will be covering basic intermediate level problems. 1, 2 and 3 which we are going to discuss. Definition, basic foundation level problems, intermediate level problems, advanced level problems, exam model questions solved. What are the concepts that we are going to discuss in LCM? First, we will discuss what is an LCM, how to find out the LCM of the numbers using various models. There are 5 to 6 ways where you can find the LCM. Then we will see which model to be used when, which model should not be used if answer options are there, how to eliminate incorrect answer options based on the models we discussed, how to find out the LCM if the numbers are given, what if LCM is given and one of the number is missing, what if all the numbers are missing and LCM is given, how to find out the set of all the numbers. For example, LCM of ABC equivalent to 361 square. What if a number is divided by multiple numbers and the positive remainder is same? Negative remainder is same. In some steps, negative remainder it is same. In steps, neither the positive remainder nor the negative remainder it is same. What is an equation method to find out the pattern of the numbers? To find out the pattern of the numbers. What if answer options are there? How to make use of answer options? Why LCM of fractions is LCM of numerator and by divided by HCF of denominator. Let us get into the class. 2.5 hours, powerful class on LCM and HCF. Let us start the class now. LCM, please write down, sir. Least common multiple. LCM, least common multiple. Least common multiple. First, before we discuss least common multiple, what do you mean by multiple? Suppose if I take 6 is a natural number, 9 is another natural number. Let me take the multiples of 6 and 9. Let me take the multiples of 6 and 9. 6 ones are 6. 6 twos are 12, 6 threes are 18, 6 fours are 24, 6 fives are 30, and so on. Any multiple of k, it is of the form 6k. K is a natural number. Any number multiplied by 6, it is of the form 6k. K is a natural number. K is a natural number. Don't take k 1 by 2. I will get 3. 3 is a factor of 6. K is a natural number. Similarly, 9 multiples. 9 ones are 9. 9 twos are 18. 9 threes are 27. 9 fours are 36. 9 fives are 45. And so on. Any multiple of 9, it is of the form 9, I will put 9k1 and 9k2. K2, it is a natural number. K2, it is a natural number. 6k1, k is a natural number. 9k2, k2 is a natural number. He is telling at some value, K1 and K2, 6 and 9, both will collide. Both will intersect. Least common multiple. So first step is, I wrote the multiples of 6 and 9. Next step is go from right to left. Take the multiples which are common in 6 and 9. What are the multiples which are common in 6 and 9? Common multiples of 6 and 9. Common multiples of 6 and 9. Let us write down all the common multiples of 6 and 9. Now if you observe closely, 6 multiple, if you observe, 6 threes are 18, 9 twos are 18. Now if you see 6 into 3, 9 into 2. So 6 into 3, 9 into 2. That is the reason I wrote K1 and K2. So the first multiple which is common to 6 and 9 is 18. Next one, 6 6 are 36. 9 fours are 36. 6 nines are 54. 9 6 are 54. 6 12s are 72. 9 8s are 72. So the common multiples are of the form 18 K3, K3, it is a natural number. K3, it is a natural number. We are defining least common multiple. Least common multiple. First, I took the multiples of 6 and 9. Multiples of 6 and 9. Then I took the multiples which are common to 6 and 9. Then I want least. Least is lowest. Minimum value. Lowest value. Or minimum value, lowest value or minimum value. 18 ones are 18, 18 twos are 36, 18 threes are 54, 18 fours are 72 and so on. What is the least common multiple of 6 and 9? It is 18. Least common multiple of 6 and 9. It is 18. I hope the definition, it is clear. Now some doubts, a student might ask, Anil sir, is these LCM defined for only natural numbers? Can I define it for an rational numbers? Can I define it for an irrational numbers? See, suppose pi it is there. Pi is approximated to 22 by 7. Pi it is an irrational number. So what is that I said? 6 and 9 could be any number. I need to write it down as 6 into K1. K, it is a natural number. So pi multiple. Pi into 1, pi. Pi into 2, 2 pi. Pi into 3, 3 pi. Pi into 4, 4 pi. These are all the multiples of pi. Similarly, if I take another 3 pi, irrational number, 3 pi into 2, 6 pi, 3 pi into 3, 3 pi into 4, it is 12 pi. These are also the multiples of pi and 3 pi. What are the multiples common to pi and 3 pi? LCM of pi comma 3 pi, it is 3 pi. Next 3 pi, 6 pi, 9 pi, 12 pi and so on. So I will get 3 pi. Very, very important key point. Write down in your notebook. Write these important key point in your notebook. Now if you see here, 6 and 9 both belong to the family of natural numbers. Pi and 3 pi both belong to the family of irrational numbers. Suppose if I want 2 and pi, 2 can be written as 2 by 1 or 4 by 2 or 6 by 3 or 8 by 4. So 2 can be written as of the form P by Q. P and Q are natural numbers. So pi, 2 it is a rational number. Pi it is an irrational number. Whenever you are finding the LCM of the given numbers, they both should belong to the same family. One rational number, another should be rational number. One irrational number, another should be irrational number. One irrational number, another should be irrational number. One natural number, another should be natural number. One rational number, another irrational number. LCM do not exist for this, because pi will become pi. 2 it is a rational number. 2 by 1, it is a 2.0. It is a truncating value. It is a terminating value. It is not a terminating value. It is a non-terminating, non-recurring. They both will never meet. So LCM should always be taken for the same family. Please make a note, sir. LCM for the given numbers should always be taken from the same family. What do I mean by same family? If this is a natural number, this should be a natural number. If this is an irrational number, this should be an irrational number. This is a rational number, another is an irrational number. LCM do not even exist. Very, very important key point, because yesterday one of my enrolled student Bishwajit has asked me this doubt in the WhatsApp. Sir, the doubt is, sir, 1 by 3 plus 2 by pi. Whenever we are solving like this, we take an LCM of 3 pi, right sir? 3 pi. But in the textbooks it is written as LCM of rational number and irrational number do not exist. But I wrote it as 3 pi. So how it is possible? Very, very good doubt the student has asked. 1 by 3 plus 2 by pi. This is an irrational number. LCM should always be taken for the same family. It is a rational number. So what you do is multiply by pi and divide by pi. Pi by 3 pi plus 2 by pi. Then we have taken the LCM as 3 pi. Then we have taken the LCM as 3 pi. I hope the idea it is clear. In case if they do not belong to the same family, make them into the same family. That is the reason LCM came out to be 3 pi. His doubt is, sir, I am referring a book. It is written that LCM of 3 comma pi do not exist. LCM of 3 comma 5 do not exist. But in this question, whenever I am doing it, I am taking, now I hope it is clear. So 2 by root 3 plus 5 by 2. 2 by root 3 plus 5 by 2. Sir, I am taking the LCM as 2 root 3, but it is an rational number, it is an irrational number. Why it is possible? It is possible because I am writing it as 5 root 3 by 2 root 3. So root 3 2 root 3. Root 3 2 root 3 both became the same family of irrational number. Then the LCM will be 2 root 3. So this will be 4 plus 5 root 3. This is an extremely important key point. The student is able to connect a beautiful concept and asked me a very interesting question. Why, when it is 3 pi, why LCM of 3 comma pi it is not possible? On this public platform, I want to appreciate Biswajit for asking a very, very good question, a logical question. Many of the students who are watching this video, I hope you got a clarity on when I said that the LCM should always be taken for the same family. How come here I am writing it as 3 pi? Because I am converting 1 by 3 into pi by 3 pi. When it is a natural number, a rational number, or an irrational number. Every natural number can be written as irrational number. How come we are writing it as 2 root 3 when LCM is defined only for the family of same number? So I am converting 5 by 2 as 5 root 3 by 2 root 3. I hope the doubt is clear to you. This is one of the very, very good doubt. Unless your fundamentals are clear, unless you have a very good understanding of the concept, you might end up solving hundreds of problems, but it does not serve the purpose if the question is twisted. I hope this is from this a very beautiful cat questions. I started creating mock questions very, very soon. We will also have in the month of March, I will also do some mock paper analysis. Yesterday night, I was creating a very, very good question. Which of the following it is true? The question will come in your mock paper 1. I hope this idea it is clear. Another important key point, least common multiple. Least common multiple. This is the generic definition of LCM. Here 2 numbers are there. Some important key points which you need to notice. If you are doing LCM of A comma B, A comma B belong to same family. A should be AK1, B should be BK2. K1 and K2 are natural numbers. K1 and K2 are natural numbers. I hope you got the idea. I will stress more on the fundamental concept. Once your fundamentals are clear, then problem solving will be very easy. Sir, here 2 numbers we found it out. 2 numbers we found it out. LCM can be for 3 numbers, 4 numbers, 5 numbers. Now if you see, if 2 numbers, if I take, there are various scenarios that will come into your mind. Suppose let me take 2 numbers, then I'll extend it to 3 numbers, 4 numbers. Suppose I took a number. Second number could be a multiple of the first number. Yes or no? Second number is not a multiple of the first number. When I say not a multiple of the first number, suppose first number if it is 6, let me take a slide. There will be so many cases. N1 if it is 6, N2 can be 12. 12 is a multiple of 6. 9 is not a multiple of 6. Or I can take 7. 6 and 7 are co-prime numbers. So when I am taking two numbers, if a first number it is a natural number, second number will also be a natural number. Second number could be a multiple of first number, may not be a multiple of first number. If it is not a multiple of first number, it could be a composite number or it could be a prime number. Like that, various cases will come. Let us do case by case. Let us do case by case. I hope it is clear. Now, method 1. Listen carefully, sir. Complete case study on LCM from the basics to CAT level we will discuss. Method 1. Write down in the same order, sir. Method 1. The entire definition is, I'll write down little down. Just give me 1 minute, sir, so that it will be perfectly clear to you. Please write down how to compute LCM. How to compute LCM. First class, I will stress more on the fundamentals. How to compute LCM. Lowest common multiple, least common multiple, both are synonyms. Least common multiple and lowest common multiple. There are various methods to do it. It all depends upon the nature of the number. Method number 1. Method number 1. If the question is like this, LCM of 6, 12. LCM of 6, 12. LCM of 6, 12. Step number 1. If I need to find out the LCM of the given numbers, step number 1. Go to the largest number. Go to the largest number in the series. It could be 2 numbers, 3 numbers, 4 numbers and so on. Go to the largest number. Check whether the largest number is a multiple of every other number. Is 12 a multiple of 6? Definitely yes. 12 is 6 into 12. If the largest number is getting divided by every other number, then the largest number is the LCM. Then the largest number is the LCM. I am repeating it again. If I need to find out the LCM of the given numbers, step number 1, go to the largest number. Check whether the largest number is a multiple of all the other numbers. All the other numbers. If the largest number is a multiple of all the other numbers, then the largest number is the LCM. First point. Second example, 15, 30 and 60. 15, 30 and 60. What are the two steps? Step number 1. Go to the largest number. Go to the largest number, 60. Check whether 60 is a multiple of all the other numbers. 15 4s are 60, yes. 32s are 60. Largest number, it is the answer. Largest number, it is the answer. Third question. LCM of 1, 2, 4, 8, 16, 32. LCM of 1, 2, 4, 8, 16, 32. Go to the largest number. Check whether the largest number is getting divided by every other number. 32. These are all the multiples of factors of 32 or 32. It is a multiple of every other number. 132s are, 2 16s are, 4 8s are, 4 8s are, 8 4s are, 16 2s are, 32. 32. Can I say these LCM, it is also equivalent to 4 8 16 32. 4 8 16 32. Largest number, it is 32. Largest number 32. 4 will divide, 8 will divide, 16 will divide. It is equivalent to 32. It is also equivalent to, I want to make a point here, 8 16 32. 32, it is the largest number. 32. It is equivalent to LCM of 16, 32. It is again 32. 32. Now this third point proves a point that just because the numbers are more, we will not get more LCM. Just because the numbers are more, here 5 numbers are there, does it have more LCM? No. as long as if the numbers inside are factors of the largest number, answer will always remain the same. Please write down in your notebook, more numbers in the LCM, more inputs in the LCM does not mean more LCM. If the number of values input it is more, that does not guarantee more LCM. I hope this third key point is extremely important. Another data sufficiency question from mock also I created based on this one. More the number of questions in the as an input in LCM does not mean that more the LCM. These are the three important. These model number one. Important observation. All these observations I am going to use it in the problem solving. Observation. See here. This is a multiple of 6. This is a multiple of 6. The given number input, both are multiples of 6. Answer is a multiple of 6. Both the three numbers input, this is a multiple of 5. This is a multiple of 5. This is a multiple of 5. Answer, it is a multiple of 5. If the given inputs all are multiples of k, answer will also be a multiple of k. Please write down. First observation. LCM of KA1, KA2. It will be k into A3. K into A3. If both are multiples of k, if the given inputs both are multiples of k, answer will also be a multiples of k. All are, if you see here, all are multiples of 4. All are multiples of 4. Answer is also a multiple of 4. Answer is also a multiple of 4. Very, very important key point. This helps us in eliminating all incorrect answer options. There are some wonderful questions which I created. Second key point. Listen carefully, sir. Second key point. If these, there are two numbers input, it is there. One number, it is a multiple of 16. Answer, it is a multiple of 16. So another input should also be a multiple of 16. That means LCM of Px1 comma y equivalent to Pz. Y should be a multiple of P. Y should be a multiple of P. Reverse is also true. Reverse is also true. It is like these examples, sir. 9 plus 12 equivalent to 15. This is a multiple of 3. This is a multiple of 3. If both are multiples of 3, answer is a multiple of 3. Why? Because 3k1 plus 3k2. It is 3 into k1 plus k2. If both the inputs are multiples of 3, output will also be a multiple of 3. If this is a multiple of 3, if this is a multiple of 3, another input will definitely be a multiple of 3. Very, very important key point. If the inputs are all multiples of some number, answer should be a multiple of that number. If one input and output are multiples of 4, another input should be a multiple of 4. Another input should be a multiple of 4. Let me take some other examples. LCM of 15, 45 and 90. We are still in model number 1. What is model number 1? Model number 1 or method number 1 is a case where the largest number is getting divided by every other number. Where the largest number is getting divided by every other number. 90 is getting divided by 15. 90 is getting divided by 45. Answer is 90. 90 is getting divided by 15 and 45. Another thing, if you observe, this is divisible by 3. This is divisible by 3. This is divisible by 3. Answer, it is divisible by 3. Answer, it is divisible by 3. This is divisible by 15. This is divisible by 15. This is divisible by 15. Answer is divisible by 15. I hope the idea it is clear. Method number 1, introductory method. Simple case, largest number is divisible by every other number. Largest number will be the LCM. If the largest number is a multiple of all the other numbers, if the largest number is a multiple of all the other numbers, then the LCM will be the largest number. Each and every important key point, I am going to take problems once I discuss the fundamentals of LCM. Method number 1. Now the second question arises. What if the largest number is not a multiple of other numbers? That will be